everyone. In this tutorial, I will show you how to create a NDVI layer and apply density slicing technique to the layer. We know what is NDVI from the lectures. Normalized difference precipitation index. It's very commonly used tool or indicator to identify surface conditions, vegetation conditions, productivity of crops, and a variety of ecosystems. And so it's a very useful, commonly used indicator, so that we need to understand or know how to create it. And it is very straightforward to create it. It's very straightforward to create it. And okay, so in the ArcGIS Pro, okay, so and we will need to understand. We need to understand we need to understand the link between NDVI values and land covers. Well, there may not be one-on-one relationships, but there are some rough links. So in this case, we need to interpret land features. Of course, we can interpret features from Landsat images, but sometimes it may be difficult to identify features only based on Landsat images. In that case, we have referred to high resolution satellite images. We can always refer to Google Earth Pro, right? So because it provides time series satellite images, which is very, very helpful for identify some challenging land features. But as we know, so we can also change the base map from topographic, to imagery. Right. And then if you have issues, just refer to this layer. Right. So for this lab, we'll need to use the file we created for lab 3, or you can use the file I shared in lab folder. Right, this one's cloud free. This one's cloud free. Right, this one's cloud free, and we should be able to change the bind combinations so that we show a standard false color composite. Right, so assign the near infrared band to the red subpixel, and the red band to the green subpixel, and blue band to the and the green band to the blue subpixel. Right, so that we get, and we know why band 5 is the infrared, right? So this is according to the band specifications. Right, band 5 is the infrared, band 4 is red, and band 3 is green. Okay. Before we do that, okay, so then, I wanted to introduce you how to do calculations in Excel, but I assume you can do it now because you finished a section of assignment relevant to Excel for lab 2. Right? So just make sure you have for question 1, make sure you have the values for forest, lawn, built up, bare soil, and water for red band and for the infrared band, and then insert or type in formula to do the calculations for simple ratio and NDVI. And I have already showed you in the class. Next, let's just create the NDVI layer in ArcGIS Pro. Click on raster functions. NDVI is here. Or NDVI colorized. Well, this density slicing, right, creates a multi-band that represents vegetation health based on the difference between the red and infrared bands. So we just want this one. Right, so the raster layer should be this one from the drop-down list. Visible band should be red band. This is vague, right? This is vague. It should be a red band. Infrared band should be band 5. Scientific output, so in decimal points. The range of the NDVI should be between -1 and 1. Created. Okay, so now, yeah, so it is being shown as in color, right? Shown as in color. Before, so we want to show it in grayscale. So let's save it as a separate file. Select data and export raster. You want to save to your Lab 4 folder. On your Lab 4 folder. The NDVI, so yeah, save, default, compression type, default, export. Now, so if you want to check where the file is, click on right-click on the layer in contents and select properties and look at the source. Right, so that's where it is saved. And so in case you don't know where your file is located. Now I want to remove this one. All right, so to show one layer as a panchromatic, so that's by default. Right, symbology, stretch, primary symbology, and check the names. We want to have a color scheme from white to black. Yeah, so somewhere here. Right. So that's default appearance for NDVI layer. Lower values, darker, larger values, brighter. Of course, vegetation, of course, looks very bright there, and water is dark. Okay. So that's for this part. Next, yeah, density slicing. Now, because we are looking at the primary symbology right now, right? Symbology pane right now, right? So we can just start from here. If you don't see it, right-click on it and select symbology, right? And change the primary symbology from stretch values to classify. Change it to groups, right? Change the groups. By default, is 5. Ledger breaks, which is the default classification method, separate the range of values by the natural gaps exist in the data, which exist in the data. It is one of the best classification method in many cases, and so we want to change to 15. Yeah, so that we have the chance to identify, okay, so what's the corresponding land use? What's the corresponding land use for, okay, for all the values smaller than -0.07, right? So we want to change it to one color, blue color or green color, make sure it is different from the surroundings, right? So it's here, all this here, right? This value. So what are they? I'll check it. Water, right? So if you're not very sure, right, that's water. That's water. Right? So the first class is water. Write it down. Write it down. Right? Write it down. Okay, on paper. Right? And we can change it to water. Right? So this one's so the light blue. Just choose one blue. Okay. Okay, how about the next one? We can show it blue or in green color. I believe it's still water, right? So this one's water too. Change it to blue. How about this class? That's between minus 0.004641 and 0.02877. Right, so that's this class. Change the green color. Should still be water, right? Look at it. It's still water. Right. What we can do too is that click on raster layer, change the transparency to perhaps 50%. The water. Okay. And change it to blue. How about the next one? Oh, it's water, right? It's water. Right, it's water. So you'll keep doing it. How about the next one? You'll keep doing it. Okay. So this is more like built up, right? So this is a different class. Okay. What you will do, okay, so for all the values, smaller than 0.083461, so all the pixels, we can assign them as water. So make sure you write down this upper value or this value there because you'll use it. You'll use it in the future. Like say you change the classes to 5, and then of course the software will create the upper value to you for you, but you will want to manually change it. How do you change it? Take this one here. Just click on it, type in the value. Right? Click on it, type in the value. Right? Okay, so so just keep doing it so that you understand the association between the values and any of their values any of their values. Right? So after you have done and okay, so you know, okay, so what's the range for water? What's the range for built up? What's the range for grass, forest, right? And there will be some confusions. So if you think some pixels may not belong to that class, that's okay. But just a few small portion of pixels, then that's okay. So after you get class breaks or upper values for 5 or 6 or 7 classes, and write them down, and you see here now change the manual interval, right? So we don't want to do it for now. We want to select the what's this one, natural break first, right? Natural break first, and natural break, and then change it back to like say if you want to have 5 classes, right? 5, right? And 6 classes, 6, and then you can manually input and the upper value and change the color like to a blue color, to a light green color for grass, a dark green color for forest, and then you create a density slicing that we can call it map. Now, right? So that's what we want to do. Stop sharing it and show new. Okay, so the density slicing map you'll be creating like this one. right? So you will show, okay, the map here, and then the value ranges, and then you will explain. So like 0.01 to 0.05, blah blah is belong to which class, right? So in your Word document, okay, in your Word document. So that's what you will need to do for this section 1, I think.